Hello everyone. Now, we are still looking at different homologous series, and what we are going to be basically looking at now, we are going to be looking at our haloalkanes, or rather our alkali halides, right? Now, let's see in terms of what is it that we can find out from these particular, family of, or rather the homologous series. Now, let's start here. You are saying this is going to be your alkanes. These are going to be your haloalkanes. And now from the word haloalkanes, the halo that is in here, it is the significance of the halogens, right? This significance, this symbolizes the height, the halogens. And remember, where do we find the halogens? The halogens are in group 17, of our periodic table. And now what are going to be those? Now those are going to be given as now your fluorine, your chlorine, your bromine, and your iodine, just to name the few, right? Now those are going to be the ones that are found in group 17. Now, which means now the alkane, which means now these are going to be the saturated hydrocarbons, right? The alkanes. Now, and now we are saying it also consists of these other significant name, which is alkali, which is AKYL, and then this is going to be halides. And the halides again still means the halogens, right? Okay. Now, one thing that you need to take note of is that it consists of the general formula, and its general formula, it's given by what? It is given by C. It's Cn. This is going to be H. This is going to be 2n plus 1, and then multiplied by the X. And the X still represent your what? Still represent your halogen, which is your fluorine, your chlorine, your bromine, and your iodine. Right? Yes, that's the significance now of your halides. Are we fine? Then now, if we can, continue now, what else can we have from here? Now, what else can we have from here is that we are going to be having its firstly now, let's see in terms of the different things that is associated with your haloalkanes. Firstly, the functional group of these. Now, this is going to be C with the C, and that is bonded with the X, right? And already we have discussed in terms of the X is the halogens, right? Which means it's these comrades here. This is going to be the fluorine, chlorine, bromine, and the iodine, right? So that is going to be that one. That is going to be bonded in here. And now there's some significant things that I want us to take note of. Now, usually, whenever we are naming our haloalkanes, right? When we are looking for the upaic name of our haloalkanes, basically, the first thing that we do is we are always going to start with what? We are going to start firstly with our halides, and then we follow with what? We are going to follow with the group, or rather the homologous series that we are having. Now, for example, if I can just give you these three significant things that I want us to discuss here. Now, if let's say I give you this, let's say you are given the bond, which is if I give you your chloromethane, right? Chloromethane. What is it that you're going to have? Let's start here. Chloro, right? Remember the chloro, which means it's the chlorine. Remember, this is going to be part of the what? The prefix here, right? The chloro, it's the one that is representing the chlorine, and the methane, now the ANE, it is the what? The ANE, it is the suffix of your alkane. So therefore, which means this is going to tell us this is going to be what? The homologous series here, it's going to be also your alkane, right? Now, what else? Now, what is it that you're going to have here? Now, meth means one. Meth means one, which means this is basically going to what? This is going to be the C that is going to be bonded with what? That is going to be bonded with the hydrogen plus the chlorine, right? So this is going to be the chlorine here. And then now this is going to be the H. This is the H, and this is going to be the H. Okay. Now that is going to be firstly your chloromethane. Okay. And now what else now can we have here? Look, we can have more than one. We can have more than one, we can have more than one halogens bonded to a carbon. And how can we have that? For example, let me just give you this. Now, if let's say you are having your bromo methane, right? Let's say you are having your bromo methane. What is going to be your methane, your bromo methane? Let's start here, right? Now, your bromomethane basically is going to be what? If let's say you are given bromomethane. Now, what is going to be that? You are going to say, firstly, what does the bromo means? This means your bromine, right? This is significantly means your bromine. And from here, which means now, and your methane. Now, look at me. Your methane, this was supposed to be your C again. This is supposed to be all that, right? So your methane means 2 because your eth is the one that means that, right? It's eth. Now, so then from here, what is going to be significant of that? Now, this is going to be your, this is going to be given as, this is going to be given as your what? This is going to be same as 1C, and these your BR that is going to be bonded here. This is going to be the H, this is going to be the H, and this is going to be the H. Now, this is the bromomethane. This was correct. Now, if we are looking for the condensed structural formula for this, the condensed structural formula for here, this is going to be just CH3BR, right? This is going to be CH3BR. That is going to be what? The structural formula, or rather the condensed formula for this particular thingy, right? And now, if let's say now you are given that you are having your what? Let's say you are having now, you are having 2 fluorine. Let's say you are having your difluoro, right? Let's say you are having your difluoro, fluoro. Now, let's say we say this is your difluoro methane. Now, your difluoromethane, what does this basically means? Now, if you are having 2 fluorines that are bonded in here, it's going to be di. Similarly, if you had your bromine, which were 2, that was going to be dibromomethane. Similarly, if this was going to be your chlorine, this was going to be your dichloromethane, right? So this is going to be also your C, which is bonded now with what? With your fluorine here and your fluorine here, and then the hydrogens here, right? And similarly now, your condensed structure, it's going to be your C. Then this is going to be your H2, and then this is going to be your F2, right? Now, this is going to be your condensed structure for this particular thing, right? So what is important here is that this the prefix here, it's always going to be the one that represent what? Your haloalkanes, right? So they are going to be significantly representing your haloalkanes. Are we together? And now you are probably asking in terms of what do we then call the iodine? Look, if let's say you are given that you are having your, let's say now you are having your iodo. This is iodo ethane. Let's say you have your iodoethane, right? So because that's the prefix of that. Now this is going to be what? Now we are going to have the iodine and what? And ethane. Eth means 2. This is going to be the 2 bonds, and this is going to be these one, right? Then this is going to be your hydrogen, your hydrogen, your hydrogen, hydrogen here, hydrogen there, and this is going to be your iodine. Right? Now, this is going to be your iodoethane. And what is going to be the condensed structural formula for this? The condensed structural formula, this is going to be given by this is going to be given by C H. This is going to be given by CH. And what else now are you going to be then given by? This is going to be your CH. And after this being your CH, what else are you going to be given? This is going to be how many carbons? This is going to be your C. Then this is going to be also your CH, right? This is CH2. CH2, then this is going to be your CH2, and this is going to be your I, right? So basically that is going to be the condensed structural formula for your haloalkane, right? That is consists of your iodo, right? Now, So basically, I think this is far as your haloalkanes are concerned. I think we are going to stop here. Thank you very much.